Solve this problem. This problem says which of the two gases, helium or nitrogen, experiences the greatest entropy change. As it states, is changed from 2000 kilopascal to and this temperature to 200 kilopascal at this temperature. So we are given the T1, so this is T1, this is T2, this is P1, this is P2. Make sure that you understand these are the formulae for the ideal gas. So these are the two formulae, and usually for pressure, if the pressure is given, you can use this one. Entropy change is the volume, is specific volumes are given, you can use this formula for finding out the entropy change for the ideal gas. So since we are giving the pressure and temperature, so I'm gonna use this this formula here to find out the entropy change. So let's do this. So Cp is average for helium, so let's do this for helium. Ln T2 over T1 minus R ln P2 over P1. So Cp from the table A dash, so A dash to A, Cp for helium, it is equal to 5.1926 kilojoules per kilogram Kelvin. And similarly the R value, so R from the same table can be found, it is equal to 2.0769 kilojoules per kilogram Kelvin. And we just have to plug in the values here and find out the answer. So let me write down this. Cp 5.1926 ln T2 is 27, so make sure you convert it into Kelvin scale, divided by T1, which is 427, so 273, and minus R, which is 2.0769 ln pressure, which is P2 over P1, so P2 is 200 kilopascal, so let me write down here units, divided by, this is 2000 kilopascals, this is 2000 kilopascals. So if you solve for this, you get about 0.3826 kilojoules per kilogram Kelvin. This is our entropy change for helium. And now we can find out the entropy change for nitrogen. So let's do this over here. So I'm gonna just use the same formula. So let's use the same formula, and so for copper, for nitrogen, this is, I'm gonna use the this for nitrogen, so let me erase this. Entropy change for nitrogen, and from the table the Cp value for nitrogen, it is equal to 1.056, and R value for nitrogen from table A dash to B, this is the table name, and that is equal to 0.29. So this, the table is A dash to A dash to A. The R value is equal to 0.2968. It's about like it's air. So let's plug it in everything, and you do the same, you get minus 0.211 kj per kgk. So looking at the nitrogen and the helium, so this is the entropy change which is larger as compared to the entropy change for nitrogen, which is smaller. So the largest entropy change is for the helium.